Hi students, in this video we are going to solve a word problem from the chapter trigonometry. The question is, if the angles of elevation of the top of a tower from three collinear points A, B and C on a line leading to the foot of the tower are 30 degree, 45 degree, 60 degree respectively, then the ratio AB to BC is, there are four options of there. Among these four, only one option is correct. So we have to find that. So let me break down the question into pieces. If the angles of elevation of the top of a tower, so we have given a tower, so let me draw the tower. For instance, this is a tower, okay, so and this is the top of the tower and this is the foot of the tower or ground level, okay. So from three collinear points A, B and C. So what is mean by collinear points? So if these 3 points A, B and C lies on a same line, then these 3 points are called collinear points. Okay, so these 3 points lies on a line leading to the foot of the tower. So there is a line which leads to the foot of the tower. Okay, so in this line, the 3 points A, B and C lies. Okay, so or 30 degree, 45 degree, 60 degree respectively. What is this? So they are speaking about the angles of elevation. So the angle of elevation from the point A is 30 degree and angle of elevation from the point B is 45 and from the point C is 60 degree. So this is the concept called respectively, the word here. So we are assigning the first thing to first one. So these are all the given things. So what is mean by angle of elevation? If the angle making from the horizontal line and to the line of sight. Okay, for instance, if I am standing here, right, so I am standing here and looking the top of the tower. Okay, so this is the horizontal line and this is the line of sight. So the angle making here is called the angle of elevation. So this is called angle of elevation, right? So and then there are 3 points, right? So this is another point and this is another angle and the third point, sorry, right. So if I stand here near the foot, I must look upwards, right, total upwards, then only the top of the tower will be visible to me, which means I have to look up in 90 degree to view the top. So when I go through some distance and view the same top, the angle must decrease, which means here I look, the angle is 90 degree. When I come here, the angle must be 60 degree, which is given here. Then the point is C. So this is 60 degree and I just move on to another point, which means the distance from the foot of the tower and myself is now more, which means the distance is increased, then the angle of elevation must decrease, which means this angle is 45 degree and the point is B, right? So point is B. Now the point is A, the only remaining thing, right? Obviously the distance from the foot is increased, which means the angle will be decreased. So this is 30 degree. So this is a given, right? So we have here a right angle triangle, right? So there is a slanting part and a straight and an horizontal part, right? We have a right angle triangle here, right angle at this point. So we just note down this point as D and this top as O, right? So we have O, A, D. So in this triangle OAD, we have a right angle at D. So the slanting part is called hypotenuse side. We just represent by HYT, hypotenuse side. And if I took this angle as my angle of consideration, then opposite to this angle is called opposite side of the triangle, and the remaining part is called adjacent side of the triangle. Also, if I have another triangle, right angle at D, right? So this is the hypotenuse side, there is no change in that. If I took my theta, that is the angle, if I took the angle of consideration here, then opposite side is, this side is the opposite side, and the remaining side is adjacent. So the thing is, the angle of the opposite side of the angle of consideration is called opposite side of the triangle, right? Fine. So here we have these things, and the height of the tower we don't know, so we just note it as h. So we need to find the ratio AB to BC. So we need to find AB and then BC. For that, we use tangent of the angle theta, which means tan theta. So in a right angle triangle, this is the situation. The formula is tan theta equals opposite side by adjacent side, right? Opposite side by adjacent side. We just incorporate this formula here. In triangle AOD, we just took the first triangle. So here tan theta is 30 degree, which equals the opposite side of the triangle is just the height of the tower, which means h, over the adjacent side is the distance from the point A to the foot of the tower. So we didn't represent any variables here, so we just note down the distance from A to B is x, and B to C is y, and C to D is just z. So the distance is x plus y plus z. So the adjacent side is x plus y plus z, right? So according to the table value of tan 30 degree is 1 over square root of 3, which equals h by x plus y plus z. We just cross multiply this. So x plus y plus z into 1 is x plus y plus z equals root 3 times h is root 3 h. So we just keep this equation as first equation, right? And then we just take the another triangle BOD. So in triangle BOD, tan of the angle is 45 degree, right? So the angle is 45 degree, and the opposite side doesn't change, it's just the tower's height. So h by, and the adjacent side y plus z. The adjacent side is distance from the point B to the foot of the tower. So y plus z is the adjacent side, y plus z. So tan 45 degree value is 1 equals, so h by y plus z. Just cross multiplying this, y plus z equal to h. This is second equation. And the last triangle COD, we just take in triangle COD, tan of, we have here 60 degree, right? So tan 60 degree equals same h by the distance is z. Yeah. So tan 60 degree is nothing but square root of 3. So everyone must know the table values of tan, right? So we just cross multiply this, z equals h over root 3. This is equation 3. So we have 3 equations x plus y plus z equals square root into h, and then what we have, y plus z equal to h. So y plus z equal to h, and then z equals h by root 3. Z equals h by root 3. Here we replace y plus z as h in this first equation. So substitute y plus z equal to h in equation 1. So this becomes x plus h equals square root of 3 times h. So this becomes x equals square root of 3 times h minus h. We just adding minus h on both sides. Here minus h and here minus h. This minus h becomes 0 and this minus h is there, right? So x equals, taking h as common, so we get square root of 3 minus 1, right? And then we need to find the value of y, because we need the value of AB and BC. So to find y, we just substitute the value of z equal to h by root 3 in equation 2, right? So yes, substitute z equals h by root 3 in equation 2. So equation 2 is y plus z equal to h. So y plus, replacing z as h by root 3 equals h. Fine. So y equals h minus h by root 3. So this becomes, just cross multiplying root 3. So root 3 times h minus h over root 3. So this becomes, taking h common, root 3 minus 1 over root 3. This is y. So we have find that x equal to h times root 3 minus 1, y equal to h times root 3 minus 1 over root 3. So we just simply replace h times root 3 minus 1 as x. So substituting x value in y, we get y equals x over root 3, right? So we just cross multiplying root 3 there, and root 3 equals x by, we get y here. So finally we get x by y equals root 3. We just write this as x by y equals root 3 over 1. So x to y is root 3 to 1. So what we have taken, x is AB and y is BC, equals root 3 to 1. So AB to BC is root 3 to 1. So that is option. So option 3 is the right answer. Thank you.